Alright, good afternoon, good morning. We're working on day 6 today. Before we start, just to point out from the test review, I did make a mistake. Because I'm not perfect. Nobody's perfect. But it just goes to show how easy it is to make a mistake in forgetting to actually answer the math question. So that's why we always double check our answers. We always make sure we answer the question they ask us. Alright. With that said, today is the day we do this in 15 minutes. Okay? I believe. Let's get started. Alright, number 1. Miss Rivers exercised for a total of 3 hours and spent 50 minutes of that time doing Zumba. What percent of her workout time was not spent on Zumba? Zumba. I have something for that. Hold on. Oh yeah, we got some Zumba music. Let's do this. Alright, 3 hours, 50 minutes. What percent of that time not doing Zumba? We're talking about percents. We're comparing a couple things. This looks like a proportion. So you can say we're talking about total time, and we are comparing that to time not spent on Zumba. So no Zumba up top. I have no idea what they're saying in the song, so if it's inappropriate, I apologize. My Spanish. No es that bueno. Alright, total percent, always 100%. We don't know the percent of time she spent doing Zumba yet, we can call that X. Over here, if we talk about actual time, well, we have 3 hours on the left, 50 minutes on the right here. We can't really mix minutes and hours, so we gotta say how many minutes would be in 3 hours. Well, if we have 60 minutes in 1 hour, to get to 3 hours, we'd say what's 60 times 3? Well, 60 times 3 is 180. So 180 minutes would be 3 hours. So we could say total time she spent was 180 minutes. Time not spent doing Zumba, she spent 50 of those minutes actually doing Zumba. We can take that away from the total time and say that she spent 130 minutes not doing Zumba. So we can say this is 130. Okay, there is our proportion. We can cross multiply. If we do 130 times 100, that would give us 130, and we just add 2 zeros to show we times it by 100. We then divide that by the number we didn't just use. That's 180. So what is 13,000 divided by 180? Well, let's find out. That'd be 72.222222222. So we can say it's about 72.22. And that's a percent up here, so we can put a percent sign. And we are done with that. Good. Alright, I'm going to stop Zumba music. Alright, number 2. Mel estimates she needs 4 yards ribbon to decorate a project. The ribbon that she wants costs $1.56 per foot. What is the total cost of the fabric? So you might think that her project was like a project board because she's doing a science fair. I don't think so. I think her project is she's growing a pig. A pig in overalls. Why does she need a ribbon? Because it makes the pig look pretty. So pretty. Okay, that's why she needs a ribbon. Let's figure it out. So 4 yards of ribbon costs $1.56 per foot. Well, we can see yards, we've got feet. That's not going to work. So let's say, how many feet are in 4 yards? Well, 1 yard is 3 feet. So that means that 4 yards would have to be This is times 3. 1 times 3 is 3. So we'd have to do 4 times 3, and 4 times 3 is 12. So if she has 4 yards, that means she has 12 feet that she needs. If it's $1.56 per foot, remember the word per just means one, so it's $1.56 for 1 foot. So if 1 foot is $1.56, how can we find the cost for 12? Just multiply. Say, what is 156? 6, not 8. 156 times 12. And we can just multiply. 2 times 6 is 12. 2 times 5 is 10, plus 1 is 11. And 2 times 1 is 2, plus 1 more is 3. Before we go to the second digit, we bring down a 0, because we're multiplying from the tens place now. 1 times 6, 6. 1 times 5 is 5. 1 times 1 is 1. We add those two together. We get 2, 7, 8, 1. We have 2 decimal places up top, which means we need 2 decimal places in the answer. So 18.72, that's talking about money, so that's $18.72. That is the cost to decorate our pig. Good pig. Alright. Number 3. Paul is going to paint a rectangular piece which measures a rectangular piece of what? A rectangular piece of I don't know. What does he have a rectangular piece of?
Cake.
Cake. Okay. He's painting a rectangular piece of cake. Awesome. Which measures 15 inches by 21 inches. Using purple paint. Because who wouldn't want to put paint on cake? Comes in tubes of 22 milliliters. One tube can cover a section which measures 3.5 inches by 6 inches. How many tubes of paint should Paul buy in order to finish his project of painting cake?
Okay, a door then.
Nope, it's too late. I've already written down cake. So, it talks about inches and our areas in inches, and it tells us this thing about 22 milliliters. Well, that 22 milliliters doesn't really have anything to do with this problem. Okay? Now, if the question was how many total milliliters would he need, then that'd be important. But since all we care about is how many tubes, it doesn't really matter how much is in each one. Okay? So there's 2 pieces. First thing we need to know is how big is our cake. And our cake is 15 inches by 21 inches.
How big is that?
That's a pretty okay sized cake. There's 21 by 15. He's got purple paint, and each thing of purple paint covers up a little bitty area of it. That's 3 by 5 by 6 inches. So the question is, how can we figure out how many of these little purple squares are in our total area of cake? So we need to find the area of each section first. So we can find the area of this. That's a rectangle, so it's length times width, or 21 times 15. If we do 21 times 15, that'll give us some number. That's 315. Okay. We can find out the area that each tube of purple paint gives us. It's still a rectangle, so still length times width, still 3.5 times 6. And let's actually work that one out. We can't be lazy all the time. 5 times 6 is 30. 6 times 3 is 18, plus 3 more is 21. So we get 21, 1 decimal place, 21.0. So if that's the area of the whole thing, this is the area that one little tube will give us. How can we figure out how many of those tubes would it take? Our last step is we'd have to divide. We'd say how many times can 21 go into our area of 315. So we can divide that out. 21 goes into 31 just once. 1 times 21 is 21. We subtract. 31 minus 21 is 10. Bring down the 5. So how many times can 21 go into 105? Well, I know 20 goes into 105 times, so let's try that. Let's say, what's 21 times 5? Well, 1 times 5 is 5. 2 times 5 is 10. Wow, that comes out perfectly. So that's 5. That's 105. I wish I could say I planned that when I was coming up with numbers, but really I just got lucky. So it's 15 tubes of paint. And if you listen very carefully, you can hear the girlfriend making herself a snack in the background. She's supposed to be doing her homework too. Slackers. Alright, that's the answer. Number 4. Jacob has a cylinder with a diameter of 12 inches and a height of 18 inches. What is B? Well, we have to remember B is always just the area of the base. If we have a cylinder, we know our base has to be a circle. So even though we're talking about this whole circle, all we care about is what is the base, what is the area of that circle.
I forgot.
So if we take a look, we know the diameter of that circle is 12, and we can find area of a circle by doing A equals pi r squared. So we can't solve for this just yet because all we have is diameter. But if we have a diameter of 12, let's just draw our circle out separately so we can see it a little better. And let's actually draw a circle. So if that diameter is 12, that means that going from left to right all the way through is 12 inches. We don't really care about that. We want to know what is the radius. What is this distance halfway? Well, half of 12 is 6. So if one side is 6, the other side could be 6 too. Oh, that's awful. Okay, that's 6. So our radius is 6. So we can say 3.14 for pi times 6 squared. 6 squared, which is 6 times 6 is 36, times 3.14. And if we work that out by hand, it would take a while. So let's do it with the calculator. And that gives us 113.04. So we get area is 113.04. Our unit is inches. Since it's area, it's inches squared. We didn't use this 18. We don't need that because that is the height of the cylinder. Now if we wanted to find the volume, we could take this area and multiply it by 18, but we don't want the volume, so we're done right here. 4 down, 1 to go. I think we're almost gonna make it. Oh, I have 33 seconds. 31, 30. Okay, quick. 2 parallelograms. One The smaller one has a base of 12, height of 4.2. The large one has a base of 18. What is the larger parallelogram's height? Parallelogram. So let's draw two parallelograms here. Looking all parallel. Big one and a smaller one. Okay, so the smaller one has a base of 12. And this height here is 4.2. Okay. The large one has a base of 18 and a height of, we don't know yet. Call that X. Okay, so anytime we talk about similar shapes, we can always do this with a proportion. We can call this, I wish I could turn off this thing that keeps me from making dots. Let's call this Big Mama. And we'll call this one
Little Mama.
not Little Mama, there's only one mama here. This will be Baby Boy. Okay. So we can use that as our key. We can put Mama on top. And she's sitting on top of the baby. Naturally. And then all we have to do is we just pick a side from our big shape. So
Mama
let's
Goose and Goose Egg.
Mama Goose and Goose Egg. It's too late, we've already named it.
Well, it makes sense.
No, it's too late, we already named it. Alright, so let's say we pick X. Then we say what side corresponds to X on our baby boy? Well, that's the height, so we need the height over here, so it'd be 4.2. Now we just pick a second side from Big Mama. The only other one we know is 18. And 18 corresponds to 12 over here on the baby. Okay, there's your proportion. We can cross multiply this and then divide. So we have 18 times 4.2. Oh. 0.2. We can multiply. 8 times 2 is 16. 2 times 1 is 2, plus 1 more is 3. Bring down the 0. 4 times 8, 32. And then 4 times 1 is 4, plus 3 more is 7. So if we add this up, we get 6. 3 and 2 is 5. And 7. 1 decimal place gives us 75.6. We then take that number and divide it by 12. Bring our decimal straight up. 12 goes into 75. Well, if I count by 12s, you can't see me counting on my fingers, but just imagine. Or use your own fingers. Ready? Count with me. 12, 24, 36, 48, 60, 72. I don't know about you, but I counted 6 fingers. So 12 goes into 75 6 times. 6 times 7 is 72. I think the girlfriend said something rude about me counting on my fingers, but whatever.
I said you were going Dora.
Hey, don't hate on Dora, okay? Dora's an inspiration. We should all try to be more like Dora. Okay? You're just Swiper over there. Nobody likes Swiper. Okay, 12 goes into 36. Wow, this works out really nicely too. That goes into it 3 times. 3 times 12 is 36. Excellent numbers tonight. So 6.3, that works, right? So we can say that this height on Big Mama is 6.3 centimeters. And let's just double check that, just because I don't know, it's getting kind of late. And my math gets kind of fuzzy sometimes. We did 18 times 4.2. Awesome. 75.6. Divide that by 12. 6.3. There you go. Alright, so we did some work on our own, we did some work on the calculator, we did some work on our own and checked with the calculator. We've done all sorts of math. Sadly, we didn't make it in time. But it's okay, because we had fun, we dressed up pigs, we did Zumba. I think this is a good homework. I give it a solid 3 stars. I wouldn't call it 4 stars. We're getting there. Alright, good night. Oh, like and subscribe, Twitter, and whatever, yeah.